We are still talking about similar figures, and now we are going to refresh our memory on some transformations. We've done a few transformations, such as a reflection, translation, and a rotation, but all of those kept the figures congruent. It did not change the shape or size. But with the last one is a dilation, and a dilation does change the shape. Doesn't change the shape, it changes the size of our figure. So for a dilation, our transformation can change the size, but the shape is going to be unchanged. It has a center of dilation, so where the central or focus point is of where it is stretching or shrinking down from, and a scale factor, which together determine the position and size of the new image after you have dilated it. So angles are going to be congruent because the shape is staying the same shape, but the sides are going to be proportional. This means that we have similar figures when we are looking at our pre-image and our image. So the center of dilation is a fixed point where all the other points are going to be transformed by that dilation. So it's a central point that's moving away from or towards. The scale factor is the ratio, so a fraction, of the lengths of the corresponding sides of your image and your pre-image. So remember, the pre-image is the original figure, or whenever we say image, that's the new figure after it has been moved. So if we have a scale factor that is less than 1, then that means it's a reduction, so it's shrinking in size. If the scale factor is larger than 1, then we have an enlargement, or it's getting bigger. So if we look at our squares over here on the right, we have square A and we have square B. So it says square A is a dilation of square B. So that means that square B is the original image, so our pre-image, and square A is the new image. So when we are comparing our scale factor, we always have to do our new over the old. Make sure you set up that fraction on your paper because it's really important that you know that the scale factor is always the new figure over the old figure. So for our scale factor, we know the new figure is our A, so we'd have 35 over the old is our 28. And if we reduce that, that gives us 5 over 4, or we could put it as a decimal and that'd be 1.25. So that shows you that it is an enlargement because it's getting bigger from the original figure. On to number 2, go ahead and graph your coordinates. So we have our coordinates right here are in purple on my picture. My dilation coordinate, the center dilation is at 0, 0. And I'm just using a different color so we don't think that that's the same coordinate that's part of our quadrilateral. So we are going to dilate this figure by a scale factor of 2. So we are going to use a scale factor of 2 to find where the new coordinates are going to be. We could answer this question right now because the scale factor is 2. We know that it is going to be an enlargement, so it's going to be getting bigger. But also you have to think of, on the previous for the squares, the center of dilation was right in the center. Here it's off to the side. So not only is our figure getting twice the size because it's a scale factor of 2, but it's becoming twice as far away from this blue point. So our coordinate of our center of dilation. So it should be further away, so double the distance away, and it will be twice as large. So it's almost going to be like in art class when you have your focal point in the background. It's like if you extend these lines out, our new coordinates will be along those lines. So it's going to be still over there to the right. On your paper, I want you to set this up, what I've written. So we are going to be counting the spacing from the center point to our point A, the center point to our point B, the center point to our point C, and the center point to our point D. Because, like I said, it needs to be twice the distance away from that point. And when we move it that direction, then it will make it twice as large as well. So we are going to be using the slope is really what you want to think of. So from the center point to point A, I can go up 1 space and 2 to the right. Now when I want to take my scale factor, I need to multiply those by 2. So now instead of going up 1, we are going to be going up 2. Instead of going to the right 2, we're going to go to the right 4. So notice both of those numbers are being multiplied by 2. So if I start at my center point and now I'm going up 2 spaces and to the right 4, that's where my new coordinate will end up. And we label our image as A prime, B prime, C prime, D prime. So it's that little notation up there. So we're going to do the same thing now for center to point B. So center to point B, I go up 1 and over 4 to the right. If we double each of those numbers, that would be up 2 and then to the right 8. So when we count that over, we will end up right here for the B prime. If we count to point C, we have down 1, right 4. When we double those, that means we're going down 2 and right 8. So if we count that, we'll end up right here, and that'll be my C prime. For D, we go down 1 and to the right 2. So down 1, right 2. If we double each of those, that makes it down 2 and right 4 for our D prime. So down 2, right 4 is right here, and there's my D prime. So if I connect all those together, my pink figure is where my new image is. One thing we're going to do later for number 4, after we get done with number 3, is that center of dilation does not always have to be at 0, 0. It can be at any coordinate. So the way that I explain this will work for any center of dilation. It doesn't matter where it starts from, that we would still discount the spacing away to each of the coordinates of our shape, and then multiply it by that number to find out what the new direction in spaces it's going to be. Number 3 is a pretty quick question. So we have 10 feet by 15 foot room that needs to be enlarged by a scale factor of 6/5. And because it's larger than 1, we know it's going to be an enlargement. And all we have to do is just take our 10 and multiply it by that scale factor. So if we multiply 10 by 6/5 and we multiply our 15 by 6/5, that will give us the new dimensions of our room. So the first one, we get a 12 exactly. And I want you now to find what is the scale, or what is the new dimension of the 15-foot side. When you multiply it, you should get exactly 18. So our final dimensions would be 12 foot by 18 feet. So just like before, set up your paper so you have the center to A, center to B, center to C, so we can count the spaces between our center of dilation all the way to our picture or our polygon that is graphed. And then we know we're going to find the scale factor of 1/2 is what we're going to dilate it by. So it's going to be a reduction because it is being cut in half. And that means that we're going to be cutting the distance in half between our points A, B, and C to the center of dilation. So there's going to be half the distance away. So it should be in between here is where our shape should end up. So now we want to go ahead and count the distance from our center of dilation to our point A. We would have to go up 6 spaces and to the right 2. That means if we take our scale factor and we multiply it by each of those, we would only go up 3 and to the right 1. So if we move there, this is where the new A prime coordinate is going to go. So if we do the same thing now from point B to point B, I have to go up 5 spaces and to the right 6. So up 5, right 6. When we cut each of those in half, that would mean I would go up 2.5, and that's okay if you get a decimal, and to the right 3 spaces, and that would be my B prime. So up 2.5 spaces, so up 2 and a little half, and then over to the right 3 spaces. Now for point C, we know we need to go up 2 and to the right 4, so that would make it up 1 and to the right 2 instead for our point C prime. So up 1, right 3, here's where point C prime would end up, and if we connect them together, you can see that it is half the distance away to our point of dilation. One thing I mentioned before is in art class you have that focal point in the distance, and if you notice, if I connect my 2 points starting from that center of dilation, it is along that same line on every single time. So every time that you are going to be moving or figuring out your dilation, you will be making your figure show up along the same lines that I have drawn on there.